Hello, this is module number 12. What do I see up here? Pretty obvious, right? Paper towels. Actually, there are 4 different brands of paper towels up here. What do you notice about them that are similar? Well, they're all white. I purposely bought all white because with this particular experiment, if they had designs, different colored designs on them, it may affect the experiment. So part of our control. This is all white paper towels. What do we use paper towel for? Well, to soak up stuff, right? Water, spills in the kitchen. If you have pets, I have cats. I have 12 cats. I know, that's pretty crazy, but I do. So I want to make sure when I buy a paper towel that I'm buying the best brand I can get. Don't want to poke my finger through a cheap paper towel into something that the cat threw up or something, right? Okay, can we design an experiment to see which of these brands absorbs the most water? Sure we can. You could have your students design their own experiment, but this particular methodology that I use has been proven to work pretty well. So this is the way I would suggest to do this. Is this the way to do it? Cup. Suppose this is just a cup of water. I'm going to take wad up the piece of paper towel, fill it with water, put it in there, sing a song, take it out, squeeze the water into the graduated cylinder. That's the way you do it? Of course not. Get rid of that. Here's how you do it. What you need for this experiment, you need a 50 milliliter graduated cylinder. You need at least 4 cups. You need a ruler. You need a pair of scissors. So let's talk about the variables. Okay, the different brands of paper towels, that's the independent variable. That's what we are changing, what we call the manipulative variable. The amount of water that's absorbed, that's the dependent variable. Sometimes we call that the responding variable. Everything else has to be controlled for. All white paper towels, that's a control. We're going to use 50 milliliters of water, that's a control. What's the ruler for? Do you think if I tear off a sheet of each of these that they will be the exact same size? No. We want to make sure these are cut the same size. You're going to cut 3 samples, 3 sheets, 3 trials of A, 3B, 3 for C, and 3 for D. I've already done that ahead of time. A is A. Trial 1, we're going to do 3 trials for each. Trial 2 and trial 3. So what size are these? Well, I've already measured them. This is 28 by 15 centimeters. 28 by 15 centimeters. So all three of the sheets cut from this one, that's the size. We're also going to cut 3 sheets from B, 15 by 28 centimeters. 3 from C, 15 by 28 centimeters. 3 from D, 15 by 28 centimeters. That's critical. Make sure they are the same size. Fortunately, they're all the same height, so you don't have to mess with that. You just have to make sure the width is 15 centimeters. So now we have our paper towels cut. Oh, it's a good idea to have your students, when they come up and get the paper towel, it's a good idea to have them write in the corner of each sheet that they tear off the letter that's inside the tube. I forgot to tell you that. Inside of each tube, write A, B, C, and D, so you can identify the paper towels without knowing the name of the brand. So this has an A inside the tube, this has a B inside the tube, this has a C, this has a D. So when the students tear off a sheet of paper towel, write A, write B in the corner, C and D, so they don't get them mixed up. You'd be surprised. Even college students will take them back to their desk and they'll get them mixed up, and I know the results when you look at the graphs, you're saying, something's wrong. We'll talk about that later. So here's our sheet of paper towel. We're going to fold it. I'm going to fold it this way. I'm going to fold it that way. I'm going to fold it like this. If that's the way I'm going to fold it, I'm going to fold each one the same way. All 3 trials of A, all 3 trials of B, all 3 trials of C, all 3 trials of D. Make sure you fold it the same way. So here's what you're going to do. We're going to have a cup of water filled all the way to the top. This will be your reserve. You don't want your students to run up to the faucet, the fountain or whatever they get the water from. You don't want them to go every time. So get your reserve of water. 1 full cup of water would be plenty of water to do all of these trials. So we're going to take the water. We're going to use our 50 milliliter graduated cylinder. We're going to fill it up to 50. Remember, when you read a graduated cylinder, the bottom, it'll be like a little curved bottom, and the bottom, what we call the meniscus, that's what you read. So you have 50 milliliters of water. You're going to put your reserve water out of the way. You're going to take a clean, dried cup, 50 milliliters of water. This is trial 1 of brand A. I'm going to fold it, well, I'll keep it folded like this. You're going to go 3, 2, 1, go. Someone starts the timer right when I say go, or when the goes in the water. You can relax a little bit, because you're going to let it absorb for 1 minute. You don't have to wad it up and throw it in. The water's going to start absorbing. It's going to do its work without you having to poke it all the way in the water. After 1 minute, you're going to lift it up. You're going to let it drip for 15 seconds. Don't shake it, because the water that's dripping is not really being absorbed. So you want that to drip back into the cup. So absorption time, 1 minute, drip time, 15 seconds. This is contaminated. It's all wet now, so you don't need this anymore. So the remaining water, pour back into the graduated cylinder. 45. So how much water was absorbed? 5, right? 5 milliliters of water was absorbed. You subtract the final amount from the 50 that you started with. Do all 3 trials of A, take the average. You're going to graph the average of the amount of water absorbed. Do 3 trials of B, graph the average, average the amount, graph the average. 3 trials of C, and 3 trials of D. So, let's see what the possibilities are on the graph that's already up here. This is fictitious. This is fictitious. We didn't do the experiment. Believe me, you don't want to watch me do this in front of you. This will take 40 minutes to do. And you know, even with younger children, you might want to label the cups, trial 1, trial 2, trial 3, because they may get confused. This is probably best for 5th grade and even 6th grade, because the older elementary students start to understand independent, dependent control variables better. But here's a fictitious one here. Which brand of paper towel absorbs the most water? On the y-axis, amount of water absorbed in milliliters. X-axis, the brands of paper towel. A, B, C, and D. A, look at A, not bad. B, B's the one that won, right? In our fictitious graph. C's really bad. And then D's actually the second best. So these brands, you can pick and choose which brand you want to use. I like to use one really good brand, either Brawny or Bounty or Viva. It's okay to use Brawny and Bounty, but you can use Sparkle, Scott, the Green Wise Public brand, just different brands. But you want to make sure you have a really good one, like this one was, and this one. If you buy all good brands, then they'll be really hard to tell the difference between some of them. You got to be careful, because students may contaminate their paper towel. Once the paper towel gets wet, you can't use that as part of the experiment. You kind of have to start over with that particular sheet, cut some more sheets. So just got to be careful with it. So I love this activity. This activity teaches independent, dependent, and control variables. If you do an experiment, any experiment, and you're trying to figure out what's the independent, what's the dependent variable, what the control variables are, you can always think back to this. If you walk back over here to over here, independent variable, different brands of towel. Dependent variable, the amount of water absorbed. Make sure you graph the amount of water absorbed, not the amount of water that's left. Okay? Dependent variable, amount of water absorbed. Controls. White paper towels cut the same size, all of them, for each trial. Using 50 milliliters of water. Folding your paper towel the same way each time. Absorbing it for 1 minute. Dripping for 15 seconds. Those are controls. What else might you consider, though? Brand B was pretty good here, right? Is it more expensive? Is it $1 more than D? Maybe D is a better bargain. So you can talk about all that. And all you have to do is save your receipt from where you buy the paper towels at, and you can share which brand is which, and you can even share how much they cost. So you can start talking about economics, you know. Is it best to buy a particular brand if it costs a lot more than another one that's just as good, you know? I use Bounty. Bounty's my favorite. Viva's good too. Brownie's not bad. If I'm just wiping up water, you know, the cheaper brands work fine, but when you really want to do some work, you get a better brand. Okay?